So up until now, in our look at XML schema, we've covered things that you would find in a typical XML and XML schema training program. We've talked a little bit about NIEM-specific things, but not a whole lot. Now here is where we start delving into the differences when you use XML schema within the NIEM. See, the problem with XML schema is that it's too flexible. And now usually that's a good thing, right? It's great to have things nice and flexible. But the NIEM needs to lock down semantic meaning of a lot of chunks of data. And to do that, it needs to put some constraints on what you can do with XML schema. The bottom line is not everything that's allowable in XML schema is allowable in the NIEM. Now, there's a whole list of what things are not allowable in the naming and design rules, in the NDR. So you can read through that torturous document and find everything that you can't do in the NIEM that you can do in XML schema. In these materials, we're going to cover just some of the major things. One of the big major differences between general XML schema and what you can do in the NIEM is it deals with local declarations and anonymous types. You can define things globally or locally, and you can give names to types or you can leave them anonymous in XML schema. Now, globally named and defined elements, attributes, and types are globally reusable. It's kind of like a global variable in code. Now, normally in code, that's a bad thing, but because of how the NIEM works and what the NIEM is trying to accomplish, globally named and defined elements, attributes, and types are indeed a good thing because they maximize the ability for reuse. They're all there available. It's kind of like having this big parts drawer available to you, and you can pick and choose the different things you need. Because the NIEM is all about reuse. That's the whole reason for the NIEM, really. You know, the idea is you get to reuse, you define exchange, you get to reuse that. Other people get to use it as well. It's a lot better than starting everything from scratch. So the NIEM loves reuse, and in the name of maximizing reuse, the NIEM likes everything to be globally named and defined. Now, the other way of doing it is to locally define things and to have anonymous typing. And that's fine. XML schema is great with doing that, and that's fine in most instances. But it's not allowed in the NIEM. Because if you've locally defined an element, then it can't be used outside of the context in which it's defined. It's stuck with being just in that one context, and it can't be reused. And again, the NIEM loves reuse. So local declarations and anonymous types are not allowed in the NIEM. They're perfectly fine in XML and XML schema in a non-NIEM context. So I don't want you to think that there's something bad about them, because there's not. But they're not allowed in NIEM work. Now let's take a look at some actual examples so you know what I'm talking about. So here's an example, and this is the same piece of schema that we just used in the exercise. Let's take a look at some different parts of it and see how they're not the way that the NIEM would like them to be. Again, this is perfectly fine XML schema, just not perfectly fine NIEM XML schema. So first let's look at that person name element. Now here in this chunk of schema, we're defining it actually inside of the person element. So you have the element name equals person, and then we start its type, and we put a sequence in there, and we say it contains a person name. Now what's the problem with that? Well, the problem with that is that the person name element is defined locally inside a person, so it can't be used anywhere else. We can't reuse it. It's not a reusable object that we could use in some other context. It's stuck inside of the person object. And because the NIEM wants to maximize reuse, that doesn't work for the NIEM. It's like a part in your toolbox, but it's a part of the toolbox that's not accessible to you. Additionally, we have other elements defined locally. Inside a person name, we have person given name being defined, person surname being defined. We have the attribute person name comment text, and way at the bottom, we also have the person U.S. citizenship indicator, although I'm not going to point to it because then the screen gets full of little pointies off that box. But we have all these locally defined elements that can't be used anywhere other than inside of a person. They can't be reused. So from the NIEM perspective, that's not the optimum way of doing it. Additionally, take a look at the typing. Person has a complex type defined right inside of it. There's no name for it. It's just the complex type for person that holds a person name and the citizenship indicator. Person name is the same way. We're defining a complex type right there inside of the person name definition element, saying here's the type for person name, but we don't have a name for it. Now what's bad about that? Well, from the NIEM perspective, again, we can't reuse them. We can't make another object that's structurally the same as a person name and give it the same type as person name because person name's type doesn't have a name. There's no way to refer to it. Similarly for person, if we have another object that's structurally the same as a person, we can't make it of the same type as person because person doesn't have a name type to refer to. And so this keeps us from being able to reuse these types. And that's not the way the NIEM likes to do things. So that's why the NIEM doesn't allow locally defined elements and anonymous types. Now let's take a look at how the NIEM does like to do this stuff. So here's an example of the same schema, only reconfigured to do things the way the NIEM likes to do these things. That means moving all the elements and that attribute down to the bottom and making them global definitions. They're all defined globally and can be reused easily because they're not locked inside a particular context. So that's all the blocks at the bottom, from the attribute name equals person name comment text all the way down to the element name equals person US citizenship indicator. Ta-da! All these are now globally defined. Now, how do we stick them into the sequence objects? Well, we refer to them instead of defining them there. So now when you see inside the sequence tags, element ref equals person given name, element ref equals person surname, element ref equals person name, those are references to the globally defined elements that are at the bottom. So it does the same thing. It says inside this sequence is a given name and a surname, but instead of defining the elements there are references to the elements that are defined globally. And now these are reusable. Also note that the typing has names now. The complex type for person name is called person name type. It's got a name. And at the bottom, where we actually have the element person name, here we see the type person name type. That allows us to reuse person name type for other elements that would be structurally the same as a person name. And the same holds true for person type about halfway down the schema. Person type is a named type. It's the type person is of. So if we had other things that were structurally the same as person, we could reuse person type because now it has a name. We could say element name equals, and some other person-y object, type equals person type. Allows us to reuse the type because the type now has a name. So that's why the NIEM does things in this way, is to provide advantages in terms of maximizing reuse. Now, is there a disadvantage to all of this? Oh yeah, just look at the schema. It's almost impossible to figure out how things fit together. You can pause and go back to the earlier schema if you like, but the earlier schema actually kind of looks like the instance document. You know, you had the person, and then you could easily see inside of there came a person name, and easily see that inside the person name was the person given name and the person's surname. The way the NIEM organizes the schemas with the global definitions and the name types, the schema doesn't really make that kind of intuitive sense anymore. You can't just eyeball it and see what the instance document is going to look like. But you know, the thing is, that's okay to an extent because you're not using the NIEM schema's whole hog as a means of validating an instance document. You're going to be building schemas based on the NIEM to do an instance document. So it's not quite as bad as it initially looks, but there's really no way around it. NIEM schemas are hard to understand. They're hard to look at an eyeball and get the gist of what the instance document is going to look like. And that's one of the drawbacks to having global definitions and insisting on name types everywhere. It's a trade-off for the sake of reusability, but it does mean that the schemas are really hard to view by hand and really get a feeling for. And that's just the trade-off the NIEM has made. Now let's talk a little bit about element cardinality in XML schema and in the NIEM. Now we mentioned element cardinality way early on when we were first looking at examples of XML schema. Those are the min occurs and max occurs that tell us how many times elements must or can appear inside of other elements. XML schema uses min occurs to say the minimum number of times that an element must appear. And it can be any non-negative integer. In other words, it can be 0, meaning that it's an optional element. It doesn't have to be there at all. It can be 1. It could be 5. You could require 5 of an element to occur. Why you would need 5? I don't know, but you could require 5 if you wanted to. You could require 100. You could really make it any non-negative integer. Typically, you see 0 or you see 1 for min occurs, but that doesn't mean it's limited to that. Any non-negative integer will do. Max occurs is similar. It can be also any non-negative integer, including 0. Yes, you can say the maximum number of times an element can occur is 0. It's kind of a way of forbidding an element. You're not going to see it very often, but it's allowable. Technically, you can do it. Again, max occurrences could also be 1, meaning I need to have 1. 1 is the max. I can only have 1 of this element at most. It can be 5. If you needed 5, I don't know why you'd need 5, maybe 10 for fingerprints, but some people have more than 10 fingers, so maybe 14 for fingerprints. I don't know what the maximum number of fingers is. So, usually you see 1, or you'll see the other one there, which is unbounded, the text string unbounded, which basically means as many as you need. I mean, technically it's kind of infinity, but at some point you're going to reach computational limits. So, don't think of it as infinity, just think of it as, Well, there's really no upper bound, as many as you need. So for min occurs, you generally see 0 or 1. For max occurs, you generally see 1 or unbounded. Now, if neither min occurs or max occurs is there, they both default to 1. Or, if just 1 is not there, it defaults to 1. So if you see min occurs equals 0 and no max occurs, that means min occurs is 0 and max occurs is 1, meaning it's an optional element, but if it's there, you can only have 1. So the way it works is if you don't see min occurs or max occurs, that means they both default to 1. You have to have 1 in only one instance of that element, and it's required. So that's how XML schema does cardinality. And that's how the NIEM does cardinality as well. But it's a little different in the NIEM schemas themselves. And let's take a real quick look at that. So when it comes to cardinality in the NIEM itself, in the NIEM schemas from which we draw upon to build exchanges, well, the NIEM always sets min occurs to 0, and it always sets max occurs to unbounded. In other words, the NIEM is optional and over-inclusive. The NIEM refuses to pass judgment on how many of an element is appropriate. It just doesn't do it. Now, part of the reason is that it maximizes reuse. You can take these, and they're all optional and over-inclusive, and then you can tighten down what you need and how many you need of different things in your exchanges themselves. So it does maximize reuse, and as we know, the NIEM loves reuse. But there's another reason as well. If you want to start defining appropriate cardinality for elements, and you have thousands and thousands of elements, you are opening a huge can of worms. You may say, well, everybody's got a last name. Well, no, not everybody does. Go talk to Cher. Go talk to Meatloaf. They don't have last names. A lot of people don't have middle names. A lot of people have multiple middle names. No matter what the element is, somebody can make an argument that it ought to be optional or there ought to be X number of them. And the thing is, nobody wants to get into that. Why should the NIEM itself be the determinant of that? It's much wiser to push that decision down to subject matter experts who are defining exchanges, right? Again, if you've got a toolbox full of pieces that you're going to build something with, the toolbox itself doesn't say which pieces you have to use and how many you have to use, because you're the one building something with it. You're the one that knows which pieces you need and how many of them you need. So again, the NIEM just provides a toolbox full of parts for you to build an information exchange. It doesn't try to tell you how many you have to have of something. Now, this is a very, 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 very important point. And the thing is, element cardinality is kind of a small topic, but depending on the community you're in, this is really, really important. If you're in the Children, Youth, and Family Services domain, if you're in that community and you deal with juvenile issues, you know that there are a lot of privacy issues involved. And it's a common mistake for people to look at the NIEM and say that the NIEM requires them to share information that they are legally prohibited from sharing. And let me tell you plain, flat out straight, the NIEM does not require any piece of information be shared. Everything in the NIEM is optional. If there's some piece of information in the NIEM that you're not allowed to share, well, then don't share it. And this is a common misconception that we run across a lot. Because there were such strong privacy issue concerns in the Children, Youth, and Family Services community, there's a lot of concern that the NIEM will require sharing of information that can't legally be shared. It doesn't. It does not do that. When you define an exchange, you define which pieces of the NIEM you're going to include in that exchange. And the NIEM in no way, shape, or form requires that any particular piece of information be shared. Again, it's a toolbox for you to build exchanges. And part of the way you utilize that toolbox is by setting element cardinality. Now, there are other ways as well, and we will get to those when we're talking further along about NIEM-specific topics like building exchanges. But know right now, the NIEM never requires you to share a particular piece of information.